Okay, so you missed lesson 6.1.3, Beer's Law. Let's talk about what you missed. First, we had a discussion about the kinds of dyes that are in food. Sometimes foods are the colors that they are naturally, but sometimes we add dyes to them to either enhance a color or make it colored. And we've been doing this for a really long time. And there have been some concerns along the way. For example, in the 1800s, they found out that candy was typically contaminated with things like mercury for bright red colors, copper for blues or greens, and lead compounds for white. All of these elements are natural, but they're toxic. So they banned the use of those kinds of metals in the United States in 1906, but they added 7 synthetic, which means man-made, color additives. And one of them that we're talking about in this experiment is yellow number 5. That's basically yellow food coloring. And the chemical name for it is tartrazine. And it's got this big old compound that we put a picture of right here. Sometimes people are allergic to these synthetic dyes. And actually in Europe, they said that we're going to ban yellow dye number 5. And so anyways, they have not banned it in the United States yet, but they have done all sorts of tests on every single kind of thing that humans eat. And what they do for every compound is figure out the lethal dose. They call it the LD50. And the way that they do this is they use rats and they figure out how many grams or milligrams will it take to kill 50% of the rats. So for yellow dye, they found out that the lethal dose is 12,750 milligrams will kill 50% of 1 kilogram rats. So that's about 12.75 grams of the dye, about the mass of 4 pennies, that will kill 50% of 1 kilogram rats. So that's kind of how that terminology works when it comes to LD50. So what we're doing in this lab is we're making a few different concentrations of yellow dye number 5, and we're going to measure how much light each of them absorbs, and ultimately then we'll be able to put in some different samples of things that we know have yellow number 5, but they don't tell us the concentration, but we'll be able to figure it out. So we're going to be testing out Gatorade and Mountain Dew. So I'm going to just sketch kind of a picture of what this would look like here. So let's see, I need a yellow pen. So if I have 1, 2, 3, 4, 5 different samples of yellow dye, and I'm going to make this one be my darkest. So this is really concentrated. This one is a little bit less concentrated, even less concentrated. And this one is just almost like water, very light yellow. So each of these has a different concentration, and we could put them in an instrument called a spectrophotometer. And what a spectrophotometer does is it shines light at your sample. So here's my little light bulb. And there's a detector on the other side. So I'm just doing it for this one. And depending on how much light the detector hits of the starting light, the instrument provides you with an absorbance reading. So the bigger the absorbance, that means the higher the concentration is. Like this one can absorb a lot more light because it has all of those chemical compounds, the tartrazine, the yellow dye number 5 in it. Versus water would absorb, in theory, close to 0% of the light because the light rays are able to pass right through. This isn't pure water, but if I also had a sample, which we will in this experiment, it's called a blank. So ultimately then, if you have a graph where you have concentration versus absorbance, it should look something like this. The higher the concentration, the higher the absorbance. And you'll be able to find an unknown and take your unknown and put it in the instrument. So let's say I've got an unknown with 4 lines. So it's somewhere in between these two. Based on the measurement that I get, and I realize this doesn't have units yet, but this will just be in general, you can actually figure out what the concentration must be in your unknown, because you're comparing it to what's called a standard curve, this one, of known concentrations absorbances. So basically, we're going to be getting the slope of this line, x, and there's an equation we can use, which is Beer's law, A equals x, c. X is the slope, A is the absorbance, C is the concentration. So then if you know the absorbance of your unknown and you know the slope, you can solve for the concentration of how much yellow dye must be in your Gatorade or your Mountain Dew or whatever it is that you're testing. So the first thing that you have to do is figure out how to make your standard concentrations. So you're given a stock solution in this lab of 0.000065 moles per liter, and you want to make a sample of 4 more concentrations so that you'll have 5 to test, including the one that you started with. So we're going to use the equation M1 times V1 equals M2 times V2, the dilution equation. And so our stock solution is going to be our M1, and our V1 is going to be our mystery, because we want to figure out how much of that stock solution do we need to add to a 50 milliliter volumetric flask before we dilute it to the line with water. So let's set up one of these together, and then you can do the other 3. So for the first one, or actually for all of these, we want to put in the 0.000065 for our M1, and our M2 is whatever we're trying to make. So in this case, we're trying to make the 0.000045 molar solution, and we're always trying to make 50 milliliters. So 50 will always go in for the V2. I'm going to divide both sides by the 0.0065 so that I can get my V1 by itself. And this comes out to be 34.6 milliliters. So let's talk about what that means. You've got this stock solution, which is the really concentrated yellow dye, and by really I mean this is the 0.000065, and you've got a 50 milliliter volumetric flask. So that 34.6 means we're going to do just that. We're going to put in exactly 34.6 milliliters of the concentrated stuff, and then we're going to fill to the line with water. We don't have to measure out the difference. What would that be? 13.4. And then when we mix those together, we're going to have a more dilute concentration. So I'm going to sketch that now like this. So now the concentration is the 0.000045. So that's the same for each of these different calculations. And so I'll let you do those. And since you were absent, you can go ahead and fill in my sample data here. Again, we should get the highest absorbance for the highest concentration. And if you're looking at someone else's data and saying, my numbers don't exactly match, well, every spectrophotometer is a little bit quirky sometimes, and so I always recommend that you stay on the same instrument during your entire experiment so that you at least get consistent results. So this is how my numbers looked for the yellow Gatorade and the Mountain Dew. I can kind of eyeball it and see that the absorbance for Gatorade is somewhere between the 0.000045 and the 0.00003 molarities, but I'm going to be able to get more of an exact answer. And same with the almost 0.5, it's between those two. So first I've got to make a graph, or next I've got to make a graph so that I can actually look at the equation and plug those numbers in. So using Microsoft Excel, you want to type in your concentrations and your absorbances, and then you want to highlight your data and insert a scatter plot. So I'm going to insert this, and I want to add a title, and I want to also add some axes. And I want to make my title scientific. So I'm going to say absorbance versus concentration versus various concentrations of yellow number 5. And then I'm going to label my y-axis absorbance. There are no units. And I'm going to label my x-axis concentration of yellow number 5 in molarity. Wonder if I can delete that. There we go. I'm going to delete my point there. Now I'm going to click on the line, and I'm going to right click, and I'm going to go to Add Trendline. And over on the right side on the bottom, I can hit Display Equation on Chart. So that's going to be important when I do my calculation, because I'm going to need that slope. So now I'm going to go back and make sure that I got everything on my rubric. I've got a scientific title, x-axis with units, y-axis labeled, and my trend line equation. And then I would cut and paste my graph here. And now is where I'm going to use that equation, paste it over here. And so I'm going to write out the equation I'm going to use, A equals x times c. And again, my slope is going to be from my graph here, 21,521 times, I'm going to be solving for c, and I'm going to go back and look at what was my absorbance of yellow Gatorade. It was 0.793. So I'm going to plug that in, 0.793, divide both sides by the 21,521, and I'm going to solve for c. And I'll do the same thing for the Mountain Dew. Hopefully you can think of some sources of error for this lab. I'll give you one hint. When light is trying to go through the sample, if there are things like carbon dioxide bubbles from a soda, that can interfere with the data. Also, contamination is always a concern, and sometimes the pipettes have a little bit of water in them from a previous mixing, and that can dilute your sample. And then working through number 3 can be a little bit of a challenge, but try to follow the hints and the steps on your own and ask questions if you get stuck on any of those.